Hey guys, Mr. Frazer here coming for you at day 3 of our e-learning math exercises for CISB. And again, we're talking about fractions, baby! Yeah! Past 2 days, we've talked about 2 different types of fractions. The first day we talked about fractions as part of a whole, like if you cut something in half, or i.e., 1/2 of a cake. Secondly, we talked about parts of a group, like if you take 1/2 of 12 cupcakes, that would be 6. Nice. Today we're going to talk about fractions along a line and using them to estimate and help us understand the length of different things. But before we do all of that, we'll talk about a little bit of vocabulary. Because vocabulary is very important, especially in math. If we don't have the proper vocabulary, it's hard for us to express our thinking and our ideas. So, here's some words to know. A couple of very important words that I want you guys to know in order to explain your thinking in this type of math are right here. First one has to do with the fraction itself, numerator and denominator. The numerator is the top number of a fraction, and the denominator is the bottom number of a fraction. You can also think about it as the denominator is the total number of pieces, and the numerator is the pieces you are talking about. Here's an example. I made a shape and cut it into 5 pieces. That's the denominator. 3 of those pieces are colored in green. That's the numerator. The next word is multiple. When we talk about multiples of a number, it's any number that you would say if you were skip counting by that number. Here I have an example of multiples of 3. 3, 6, 9, 12, 15, plus 3 more, plus 3 more, plus 3 more. Basically, if that number is divisible by 3, it is a multiple of 3. But what's divisible? Good question. Divisible is any number that is able to divide up equally by that number. So 30 divided by 6 equals 5. 30 is divisible by 6 and by 5. We will use these 2 words to help us do this, reduce a fraction. The first fraction I have here is 15/30ths, or 15 over 30. This number and this number are both divisible by 5. So I can divide 15 by 5 and 30 by 5. If I do that, I get 3 over 6, 3/6. But 3 and 6 are also both divisible by 3. So if I do that again, I get 1/2. Here I've reduced the fraction twice in order to get an easier, more understandable fraction. A few other words I want you to know today are estimate, which means to make an educated guess. Think about all the information you have and guess on what it might be. Column, which is the direction going vertically in a table. Row, going horizontally in a table. And then, of course, just table, a way to keep our information. So these are words we're going to need to know for the unit. I hope you understand them. If not, send me an email. We'll figure it out. Next, let's do a little warm-up activity. All right, guys. So what I asked you to do is I asked you to take a look at this line and these shapes and make a couple estimates. Okay? So what I want you to do is I want you to think about this line almost like a race. And this is the start of the race, and this is the end of the race. And each shape is a different runner. Right? So what I want you to think about is how much of the race, what fraction of the race, has each of these shapes completed so far. So I want you to just take a second, pause the video if you need, and write down a couple estimates about what you think the fraction would be that represents how much of this race, or how far along this line, each shape is completed. I'll give you a second. Great. Now, if you need more time, go ahead and pause the video. If not, just go ahead and jump in and figure out some of the answers. The next thing I ask you to do is to take this ruler and expand it to meet the length of the line. That way we can check our estimation. So I'm going to go ahead and I'm going to move this ruler here, and I'm going to make it bigger, about, let's say, right here. And you move it over to match the line just a little bit. There we go. That's close enough. So now I have my ruler on the red line. In fact, you know what? I'm going to move it down, make it even easier for ourselves. Put it right there. Beautiful. Now what we have are these shapes along a measured line. And it's a little bit easier for us to make some fractions. So if we look here, our line is broken into 6 segments. So our denominator is going to be 6. If you look, the red circle, the blue triangle, and the purple pentagon all fall right on a mark with those lines. So these guys are really easy to figure out. This guy is 2/6. This guy is 3 out of 6. And this guy is 5 out of 6. But we have a little bit of a tricky situation when it comes to the green square and the orange diamond. They don't fall on one of those measured lines. In fact, they fall exactly halfway between 0 over here, 1, and 2 and 3. So we can't say 2 and 1/2 or 1/2 here because we're measuring in 6. The whole line is one whole. So we need to figure out what we can do. And what we can do is we can divide each one of these benchmarks up into 2 more. So instead of this being 1, this could now be 2, with this being 1. This would be 3, 4, 5, 6, 7, 8, 9, 10, 11, and instead of 6, we now have 12. So instead of measuring by 6, we're measuring by 12s. Now we're breaking it up by 12s. The same line, the same distance, it's just now we've added more benchmarks in order to be a little bit more accurate. So now, for the last two, our denominator is going to be 12. If we look, the green square falls directly on 1/12. And the orange triangle, or sorry, orange diamond falls directly on 5/12. Okay. So for the most part, we're able to figure out our fractions. But there's something a little tricky about these two. These two fractions can be what's called reduced. And we talked about that just a minute ago, is reduce is making the fraction smaller or simpler. In fact, some people call reducing a fraction simplifying a fraction. So what we're going to do is we're going to try to make these two more simplified by thinking about what number each, the numerator and the denominator, are divisible by. Right? So if we think about 2 and we think about 6, we know 2 is only divisible by 1 and 2. Right? And 6 is divisible by 1, 2, 3, and 6. So we think about what number is the biggest number that they're both divisible by, and that's 2. So all we do is we divide by 2 on the top and the bottom, and we get 1/3. With 3, 6, we go through the same process. What numbers are 3 divisible by? 1 and 3. What numbers are 6 divisible by? 1, 2, 3, and 6. What is the largest number they have in common? 3. So we divide by 3. And we get 1/2. Okay? And these are our reduced or simplified fractions. We're going to do that more today with our table work. So I'm going to grab my tools, I'm going to grab my ruler, I'm going to grab a piece of paper to make a table, and I'm going to go on over and I'm going to sit down and I'm going to show you what to do next. Guys, welcome back to the table. Today we're going to do some stuff with the ruler. Right? Hopefully you have one of these rulers at home. If not, it's going to make things pretty difficult. See if your parents can't pick one up for you, or maybe borrow one, or you could use a measuring tape if you have one, but it would be a little bit more difficult. Having a ruler would be best, because what we're going to do today is we're going to use a non-standard unit of measurement. And we're actually just making this unit of measurement up, and we're going to call it R's, standing for rulers. Now, one ruler, 1 R, is equivalent to 30 cm. So that's what we're going to use as our base today, right? So what I wanted you to do is I wanted you to make a table with enough space to measure 10 different things. And on that table, I wanted you to have a couple different columns. Your item column, which is where you label the different items that you measure. Your estimation column. Your CM, which is your measurement. I'm going to have you measurement in CM. And then I'm going to have you convert it into rulers, or R's. And we're going to use fractions in order to express the length of different objects, okay? So what we did here was we went ahead and we made a table, and we got some things that we are going to measure. So I'm going to measure my phone here. I'm going to measure an iPad here. I'm going to measure a water bottle. And I'm going to measure a chair, but I can't really fit the chair onto this table. So I'm going to just do that one in my head here. Okay, here we are, and we are going to start with a phone. Okay, here's my phone. I'm going to go ahead and estimate here. I'm not going to hold my ruler up to it. I'm just going to kind of have it by here. I'm going to say, you know, it looks a little bit bigger than half to me. So I'm going to say maybe 3/4. 3/4 R. That's my estimate here. Now, go ahead and measure by lining it up here to here. And I get exactly 15 cm. Now, if I convert 15 cm to R, it's less than 1, so I would write 15 over 30 R. Because 30 cm is 1 R. So here we have 30, we have 15. So this is the fraction that represents, the length of this phone. Next, I have the water bottle. This water bottle looks pretty big, so I'm going to estimate that it's 1 R. Okay. Now I'm going to lay it down to measure. I'm just going to mark the bottom and the top and get this guy out of the way. Measure it here, and I get 23 cm. If I make that into a fraction, 23 over, yep, you guessed it, 30 R. Now, iPad time. iPad looks pretty big. If I broke this into 3 pieces, I think that the iPad would be 2 of those 3. So I'm going to say that it's 2/3 R. Okay. Place it on the top, and I find that it's exactly 20 cm. Okay. And to write that as a fraction, 20 over 30 R. Easy. Last one's the chair. And I estimated the chair was pretty big. I estimated that the chair was 3 R. And when I measured it, it was 80 cm. So if I make that into a fraction, it's 80 over 30 R. Perfect. Okay, now you may think, great, I'm done. But that's not true. Earlier in this video, we talked about something called reducing our fraction. And if we look at our R column here, there are some fractions that can be reduced. Let's take a look at the phone. 15 over 30r. Now, I don't know about you, but very rarely do I hear somebody refer to something in 30ths, 15 30ths. But what we can see is we can look at these and realize that this fraction can be reduced. Right away, I see that it ends in a 0 and ends in a 5, so I know that it's a multiple of 5. So if I decided to divide by 5 on both sides, I would get 3 over 6. And because I'm a great mathematician, I can see that 6 is divisible by 3, so I can divide each one by 3. And that would give me 1/2. So if I wanted to reduce this fraction, 15 over 30, I would reduce it to 1/2. Easy. The next one I want to talk about is this, 20 over 30. Can you think of what number these are both multiples of? If you said 10, you're correct. So if I divide 20 and divide 30 by 10, I would get 2/3 r, which was actually my estimate all along. Very cool. Now let's erase this and let's do the water bottle. 23 over 30. I know 30 is divisible by 1, 2, 3, 5, 6, 10, 15, and 30. But is 23 divisible by any of those numbers? It's divisible by 1, not 2, not 3, not 5, not 6. In fact, 23 is only divisible by 1 and 23. And there's a special name for that kind of number, and it's called a prime number. 23 is a prime number because it's only divisible by 1 in itself. So we can never reduce a prime number in a fraction. So 23 over 30 is exactly what it's supposed to be. So that one gets to stay. But what about 80 over 30? Ooh. Sorry for that, 8. There you go, that's a little better. 80 over 30. Can 80 over 30 be reduced? Well, yeah, they're both multiples of 10. So if I wanted to divide by 10, I would get 8 over 3. But hold on a second. I thought the denominator was supposed to be bigger than the numerator. And in most cases, we're correct. So what I'm going to need to do here is change this fraction. And there's actually a special name for this fraction called an improper fraction, where the numerator is larger than the denominator. So all I have to do is subtract the denominator from the numerator, and that will become 1 whole. So if I subtract 3 from 8, I would get 1 whole and 5 over 3. But that's still an improper fraction. So I would subtract again, and now I would have 2 and 2 over 3. 2 and 2/3 r, which is our reduced fraction. Now, there's also a special name for this called a mixed number fraction. That is what we have here, where we have 2 wholes and 2/3. Okay? And that's the simplest way to write 80 over 30. So your job is to create your table and then post it onto Seesaw with reduced fractions in your R column. I'll go on and I'll take a look and I'll give you feedback on your reductions and see if you can make any improvements. Then we'll get better from there. So a lot of new words today: numerator, denominator, multiple, divisible, mixed number fraction, imbalanced fraction, or improper fraction. All of these new words today will help us be able to describe and show our learning of fractions. So I hope you had a good time. I hope you learned something. Rewind the video to different parts if you want some clarification, or send me an email. I'll be able to help you out. All right, guys, have a good one.